I have a secret trick I can do, which is this. If I feel like, guys, I underestimated how much room my control circuitry is going to be, I'm just running out of room, guys. I can't even fit as many motors as I thought. It's just getting too hard to work with, and I need more room for this robot. I need more room. Check it out. How does a body get more room? I'll show you how. In real life, too. This is how a body gets more room. I think you guys get where I'm going with that. If you're American, this should look pretty familiar to you. This should look like pretty much everyone you see walking down the street. And then it's like, even... It's like, guys, we got room for a lot more motors now. You know what I'm saying? Like, bro, that's all you gotta do. Make your robot fat. And it'll probably look more realistic. To have an obese robot. But now, because this is what they do. They slap a backpack on it. That's what everybody does when they're like, oh, guys, we need more space. Like, we don't have enough room. And so everybody gets a backpack. And... that's what I was going to do too. Don't get me wrong. I'm not judging. It is a smart solution. It's, you know, it's reasonable. But when you give a robot a backpack, it's like cheating. It's like, oh, you failed to fit all of your engineering. Look, see? Backpack. So it's like, okay, guys, we need more room. The robot's body is just full of stuff. We need more room. Sorry, guys, we ran out of room. Okay, we'll just slap a backpack on it. That's what everybody does. But it's like annoying because it's like you failed as an engineering team. You failed. You put a backpack on it because you failed. We all know that if you could easily fit it in the robot, you would have. So you had to create like this external thing. And no one wants to see that. Imagine if I, as a human being, had to carry a backpack on my back my whole life, which had some extra organs God just couldn't figure out how to fit. So my stomach and maybe my heart and half of my intestines are in a backpack I have to carry around. That would suck. Like, that's ridiculous. So, no, I don't want to have a backpack on my robot at all times. That would be awful. So, though I can see a backpack to go being a great solution for long-term non-access to a power outlet, like mowing the lawn or taking a trip to the grocery store or whatever, slapping on a backpack is a reasonable solution. But for the most part, for internal use, traveling from room to room, whatever, I want the robot to not need a backpack. Or for demonstration, like, you know, like if the robot's just doing a YouTube video or like a prank video, like the robot's supposed to see if it can talk to somebody and they don't even know it's a robot, or try to scare somebody by somebody thinking it's a human then realizing later it's a robot. Just kind of playing around with ideas like that. In that type of scenario, I would definitely want. Um, oh, I lost my stirrup pulley that we made earlier. Anyhow, I can easily make another one. Since our pulleys are so simple, it's a matter of just cutting off a little piece of tubing and stringing it up, no problem. In fact, you could even, you know how like you use a wire stripper to strip your electrical wires? Even just a little bit of that from like a jumper wire that you stripped, even that could be one of my pulley stirrups. But I think the Teflon tubing is superior to that though, because that's like some type of plastic that may not be as slick and slippery as the Teflon tubing, which is like super slippery and slick. It's got a very, very low friction surface to it. So I love it for that. Alright, so yeah, what I was getting at is if a robot runs out of space and you're like, backpack time, press pause and say, but hold up, what if we just make the robot fat? I mean, you could make it like a bodybuilder too, just give it giant muscles, but that's not realistic looking. Very few people have giant muscles. The best way, first of all, like a lot of men just have a beer belly, but they're not fat all over. So you could start off with that. If you need more batteries in the robot than are fitting, you just give him a big gut, but he could still have standard size legs and arms. And I want to try to pull up a picture of that. So here we have perfect example of what I'm talking about. In fact, the robot, I might make it kind of an old man anyways. Think of how many batteries you can fit in this giant beer belly, and yet the legs and arms are still skinny. This is a very, very common body type. So there's your backpack, except it's a front pack. And it's all integrated into the robot's body so that there's less giveaway, hey, that's a robot, because it's not wearing some cool looking backpack. Now granted, you can put it in something that looks more like a book bag or whatever, but how many people do you see walking around carrying a book bag everywhere they go? It'd be much better, especially like if he's going to go into a grocery store. What if somebody's like, hey, we got to check your pack, are you stealing stuff? It'd be better if he were storing any extra batteries or circuitry or whatever in a big gut. Nobody's going to say, hey, stop. Is that your real gut? Let's lift up your shirt. We're going to search your big beer belly to make sure it's not actually merchandise you're stealing from the store. Can you imagine? They would like have to stop everybody in America because they're so fat. So no. Nobody searches somebody to make sure they're not hiding things in their fat. Because they might have like a bunch of product and it just looks like a beer belly, but it's actually just a backpack under their shirt. But no, nobody thinks about that because so many people are actually fat. Very few people probably have a storage container that looks like a beer belly, but it's actually not a real belly. It's actually a backpack under their shirt. So that's something unheard of. So what I'm getting at then is having extra battery capacity or whatever you need more room for, that's the perfect place to put it. But as I've demonstrated here, why stop there when you can also just make the butt and thighs and calves and arms way bigger everywhere, even man boobs. Now suddenly you've got way more room for anything you want to put in the robot. So yeah, that's just an excellent solution I came up with. Oh, and look, you can put a lot more width here, and even love handles and stuff. I mean, you could fit so many more motors and components that way. So I'm actually really excited about the possibilities. Now, that's backup plan though. Plan A is let's make a fit bodied robot. I mean, why should I make a obese robot if I can avoid it? It's like, no, it's going to take up too much space now, whatever. But if I'm finding, like I said, because in the prototyping or the design phase, it might be like, yeah, we'll find room for everything. And mainly my goal was to fit all the cooling systems in, some of the battery systems in, and the motors in. That was my biggest concerns. But what about all the motor controllers? Oh, and I put the main onboard main brain's computer in there as well. But it's like, what about all the motor controllers? I didn't actually design and implement that into there, so where are they going to fit? Now, we've seen that with my little baby, with my little baby size brushed DC motors, we've got right here the motor controllers taking up no space at all. It's just mounted right onto. It's just a little H bridge on a little development board. It seems like it's part of the motor. It's only taking up like maybe 4 millimeters height added to the outside of the motor. It's just not significant. But when you get into the motor controllers for brushless DC motors, those motor controllers are no longer merely H bridges. Now you're dealing with a double H bridge plus sensory inputs plus a bunch of actually it might not be that bad. I'm gonna have to revisit that because I did a diagram and it's showing a lot of MOSFETs and stuff, but if we use double H bridge chips we might be able to do something. Well, no, because it's those H bridge chips are only designed to do like L9110S. Let's see, L9110S H bridge. Let me look at the stats on it. 2.5 to 12 volts, 800 milliamp continuous output. See that? Let's see, what does it say for the brushless that we're looking at as our next size up? You can see actually I sculpted out to scale all the different size motors we're working with. This starting all the way from a scooter one all the way down to little baby size ones like this. Which one is this? Oh, that's the micro N20 motor. But this is the one we're using for the fingers. It is the brushed DC motor size 140 motors is what they're called on eBay. And then this is where we start getting into brushless motors, which are way stronger. They're $11 a piece, size 2430, and they run at 24 amps. Now, as we just saw, 24 amps cannot be handled by these 800 milliamp continuous H bridges. So once you're getting into 24 amps, you have to use actual N-channel power MOSFETs. And when you get into that, as your H bridge, now you need 4 MOSFETs as the H bridge, plus you need all the additional discrete components to run all of that. Like you need little resistors, and I don't think they're logic level MOSFETs, so I think you need like 10 amps to run them. So you actually need to have a logic level, I mean you need 10 volts to turn them on. And since Arduino can't output 10 volts, you need to have a separate power supply to actually power them. And then the Arduino turns off another switch that actually turns on and off that power supply, leading to your power MOSFETs. So, and we've gone through that, we've got demonstrations of that, but the main thing with that is you're talking about a much larger and greater profile of components because it's not all integrated onto a single silicon chip. And then you're also possibly even going to need heat sinks at that point. And so that's going to add even more space. So the space is going to get eaten up real quick. And that's a great concern to me. I might even, well, but it's like I'm going to have space. Like, okay, if you look here, like here's all of our motors on the arm, but like we could put MOSFETs and whatever like above them, you know? Like there should be some gap between like where the muscle would end and where the motors end, and we could try to fit like long, skinny circuit boards, homemade, like up and down on top of the motors. So I'm hoping that we can then work out through custom circuitry, uh, being able to fit all of that. And actually, to design like small, sleek circuitry that's flat profile that can fit between the motors and where the muscles would end inside the arm, between basically the exoskeleton mesh and the motors. To be able to do that type of circuitry, I'm probably going to take my big blown up 2D schematics I made in Photoshop of the brushless DC motor circuits and recreate those schematics with actual 2-scale 3D models of each of the components, and then rearrange it all in a 3D form factor with the low profile and the elongated form, but narrow and elongated, in order to establish how that's all going to look and how to arrange it all and get it organized. And then being able to produce that in reality with components and all the measurements. Even we could maybe even 3D print like some type of guide board with labels on it or something. That will kind of give us a frame of reference for how far apart things can be and what all the wiring is going to look like as just a physical thing to compare with. That's a potential thing. Or we just look at our monitor and see where everything's at. That will help me a lot in actually constructing it. And that's something that I'm excited to do, is rather than just create a 2D schematic and then in 3D it looks nothing like the 2D schematic. So you're just trying to find out what goes to where. No, first, while still on the computer, you convert the 2D schematic to a 3D schematic with how it fully looks physically, and how it's laid out. You get the spatial dimensions just right. You can really make it more efficient and compact that way. And then you can construct it a lot easier. So that's where I'm at. That's the update. I thought it was really fun labeling everything. It's just, it makes it so much less overwhelming to see labels on all the wires. Because I feel like, man, if someday I actually have to figure out what all these wires are doing again, that's going to take forever. But since I labeled everything, now anytime I need, like a wire comes undone or whatever, I'll know exactly what's going on, where that wire was heading to, what the purpose of the wire is, why that wire could be my culprit. If something's going wrong, I'll be able to locate the wire that's most likely the problem wire. It's just going to make life so much easier and better having all these wires labeled. I'm so excited about that. That was such a great addition.